Hi there, this is Mike. This is my mixing experiments for Alexi. You'll see a bit of explanation as we go through the thing. My workbench, a computer and the smart level and a vessel to mix the solutions in. The smart level is behind the stirrer. This is my syringe that I use to inject the dyed conducting liquid in at the top. Found just putting it at the top was the easiest. And then with the stirrer on, you can just and I'll video it, and then be able to see the effects of the how the liquid is flowing around. And then using the Smart Level Lab software, we'll be able to track the resistance at the top and at the bottom. Using the data, you'll be able to see how long it takes the liquids to mix, which is obviously the intention of this whole exercise. And here I'm going to show you now. That's just a test injection. Mixing very slow rate, 60 RPM. And now I'm going to take you into the Smart Level Lab software. So it's a program that we can replay a pre-recorded file. So this is I'm replaying it now, an experiment that I did earlier and videoed it, and I pick up the file, all the data saved to it, and then I can extract various sets of information out of the raw data. It gets replayed back, and I can set watch lines and resistance measurement points along the probe. I can set various sampling times and various things, and I can extract it from the data as it comes back. It plays back in real time, about 12 or 13 readings per second. Start the stirrer. Six 60 RPM. Okay, so I'm going to just put a dot. It's about 1 cc. Maybe I'll try a bit less this time. Half a cc about. Okay, here we go. So now you'll see the resistance dropping at the top. The green line is the sensor number 100, which is right near the top, and the purple line, okay, this is what's happening along the length of the probe. On the right hand side is the top and the left hand side is the bottom. So as we add conducting liquid, you'll see that the resistance drops as it migrates its way down from the sensor number 100 to sensor number 5. Maybe another, it's a 1 cc this time. Here we go. So having added some more conducting liquid, you'll now see the graphs dropping. You'll see the liquid appearing. There it comes. You'll see the density at the top in the column, showing that it's more conducting, and you'll see the liquid, the conducting liquid, migrate down the length of the probe. And what we'll show, you can see and there's a delay between the bottom sensing and the top. You'll see quite a few seconds delay. So here now we see the profile along from right. Right is the highest one, and left you'll see the profile, how it dropped, how the conducting liquid made its way down the length of the probe. So this is quite an effective way of seeing what's happening. So here we're seeing it again, and now we're going to shortly be adding another dose of conducting liquid to see the effects of that. So now the conductivity along the length of the probe is fairly constant. That means the mixing is kind of completed in my view. So now we're going to add another shot and see what happens. Okay, maybe another 1 cc, 1 or 2 cc, 2 cc this time. There we go. Okay, so having added another dose of conducting liquid, you'll see the two conductivities, the resistances drop first at the top sensor number 100, and then shortly thereafter at sensor number 5. The mixing looks a bit faster this time. I think I upped the stirrer speed to 100 RPM. And we'll have a look. There is one sensor pin that's not working. That's that white line in the middle on the bar thing. So just ignore that. This is what the profile looks like when we there he comes. There it comes. You can see it going from right to left, working its way down the probe, and then becoming fairly constant once the mixing is completed. Here's a graph of all the changes over time, and that's the end. Thank you.